Hey guys, okay, this is chapter 5, section 1, atoms bonding in the periodic table. So the reactivity of elements, it's all related to the valence electrons, and the number of valence electrons determines the properties of that element. So everything that's in the same group or family on the periodic table have the same number of valence electrons, and it determines how they bond with other atoms. Okay. The number of valence electrons in an atom determines its properties, like we said before, and everything wants to make sure it gets to 8. That's the magic number here. You're going to see these dots here. This represents the number of valence electrons. So hydrogen always has 1 valence electron. Carbon has 4. And you see how they're spread out evenly on all sides of the symbol. Oxygen, it has 6. And it has 1 on each side, and then it goes again and puts a second one on the right side and the second one on the top. So what does the periodic table tell you about the atoms? It tells you the atomic structure if you know how to use it right. If we're looking at the periodic table, these are the group numbers up here, 1 through 18. But if we count using each column, each group number, but omit the transition metals, that they vary, so we're not going to learn that in 8th grade. You can learn that in high school chemistry. We can determine the number of valence electrons. So this would have 1 valence electron. Everything in this column has 2 valence electrons. Everything in this column has 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons. And remember, this is not the total number of electrons. This is the number of electrons in the outermost level. So when we do a dot diagram, this is not, again, it's not showing us all the electrons. It's just showing us the valence electrons, the electrons in the outermost level. So phosphorus is in group 5, and what we do is we put a dot here. This is position 1 on the right-hand side at the top. You can almost think of it as a box around each element symbol. That would be the first dot, second dot, third dot, and fourth dot, and then we go back and put another dot. So that would represent 5. So these are the steps. You write the symbol and locate the element, count the columns, and figure out how many valence electrons. And then we go ahead and we start down here. Place the first 2 dots on the right side of the element symbol. This side is referred to as the s orbital. Place the remaining dots in a counterclockwise fashion around the symbol. So we always go one step at a time. If we were looking at lithium or sodium, they all have 1 valence electron. They're in group 1. That's how we would write it. Magnesium and beryllium, that's how we would write it. Boron and aluminum, that's how we would write it, and so forth. And you need to know what a chemical bond is. And the chemical bond is the force of attraction that holds 2 atoms together as a result of the rearrangement of electrons. It's the positive and negative. When something loses an electron, it's going to end up having a positive charge because the number of protons outweighs the number of electrons. It's not a stable atom anymore. And so it has more positives than negatives. If it ends up gaining electrons, it's going to have more negatives than positives, so it's going to have a negative charge. And we'll go into that a little bit more with ionic bonds. And that's it.